physics students, and happy May. It is now May 1st. We made it through April. Let's get through May and then wrap up in June and see what we can do. Okay, I want to go give you a little help with this worksheet that I posted for you to do today. There are 4 problems up at the top. Let's start taking a look at these 4 problems. You will see that I did include the answers for you. So when you do these problems, you can check for sure to see if you got the correct answer. So that's not a problem. All right, let's talk about these 4 problems up at the top first. All of these 4 problems up at the top use the same idea of momentum and impulse, right? So all of these will use one of these formulas, right? Remember this whole set of formulas. Ft equals impulse, which is equal to the change in momentum, which is equal to mass times change in velocity. Okay, so let's take a look at this first problem. Okay, so this first problem says it takes 20 newtons of force, 7.25 seconds to stop a 6 kilogram object. How much impulse was imparted? All right, so I got the mass. Good, so I'm looking over here. To stop, which means it goes to 0. Oh, but I don't know what velocity it starts at, so I really can't do a change in velocity. But I've got a force and a time interval. So it looks like I can use that side of the equation. I come over here and say Ft, force times time, equals J. So my force, 20 newtons, times 7.25 should equal J, the impulse imparted. And when I multiply those two things, I should get my answer. Now, if you can't write on your paper like I am, you should at least add some information to the paper for me. So even if you want to do it with typing, right, you can just type right in here, Ft equals J, and then just put it in there. 20 times no, come on, 20. Oh, there it is, times 7.25 equals, and then you answer. So do show me some amount of work. Don't just type in an answer. Okay, so let's take a look at problems 5, 6, and 7, which are all going to be conservation and momentum problems. All right, let's take a quick look at those. Okay, so like I said, they're all going to be conservation of momentum problems. So our conservation of momentum formula, the initial momentum of a system is going to equal the final momentum of a system. So m1 v1i plus m2 v2i is going to be equal to m1 v1f plus m2 v2f. Okay. Now, all of these particular problems are going to start with an initial momentum, right? The object's initial momentum, or not the object's, the system's initial momentum is going to be 0 because both objects are going to start at rest. So the initial momentum of the system is going to be 0. That also means then that the final momentum of the system is going to be 0. Now, the only way that can happen, since momentum is a vector quantity and the direction of the momentum matters, is if one velocity is in the positive direction, thus giving a positive momentum. And the other velocity is in the negative direction. So that when I add the two momentums together, they'll come up with 0. Okay, so remember the initial momentum is going to be 0 because both objects are at rest, making the final momentum 0. One object has to go in the positive direction. The other object has to go in the negative direction. That's the only way we can have a total velocity or a total momentum of 0. All right, so good luck on these problems. Please remember to stay safe, stay healthy. Contact me if you have any questions. Don't forget, if you're missing any of the work that's been assigned already, you can always go back and make that up. And your grade in eSchool is up to date. I've been trying to keep that up to date daily so you know where you stand. So please get through, make up all that work, and let's just keep working hard.